Today I'm going to go over a new topic with you. It's on physical properties and chemical properties and physical changes and chemical changes. So the essential question for today is, how do I know the difference between a physical change and a chemical change? So the first thing you have to do is look at properties, so physical and chemical properties. Physical properties are just basically ways to describe a substance. So melting point is a physical property. Each solid that you see has a very definite melting point. It melts at a certain temperature. That's the same for boiling point. Everything has a certain boiling point, so it boils at a certain temperature. Density is a physical property because it's based off of how close the particles are together. If it's a solid, you're going to have particles that are really close together. If it's a liquid, the particles are able to move around each other, still pretty close together, but able to have a fluid movement around each other. And then the gas particles are really far apart. They're really spread out. You have an increase of energy as you go from a solid to a liquid to a gas. So the energy increases. Therefore, the particles are moving around faster and they're spreading further apart. Okay, so density is basically just how close the particles are together. So the most dense, of course, is going to be solid, then a liquid, and then the gas is the least dense. It's still, if you're going from a solid to a liquid to a gas, it's still a physical change. So a change in the state of matter from a solid to liquid to gas. It's still, if we're talking about water, if we have an ice cube and it melts and then we boil the water, it's still water. So it was just the particles close together, then the particles moving further apart, and then even further apart. But it's still water. So that would be a physical change. So any change in the state of matter is a physical change. So physical properties just kind of describe it. So melting point, boiling point, density, color, like if you're just looking at it, describing it, and texture. So if you're describing how it feels. Chemical properties are going to be describing how that chemical reacts. So if the chemical reacts with oxygen, does it burn? Does it rust? If it reacts with acids to produce a gas. Those would be chemical properties. So it's basically just telling you how that chemical reacts, what it's going to do in the presence of other chemicals or substances. Chemical changes are going to form a new substance. Now we said physical changes it's going to be the same substance. It does not change it. That would be like if you rip paper, or if you crumple a piece of paper up, it's still paper. You just physically changed how it looks. A chemical change is going to form a completely new substance. So if we're talking about the paper again, a chemical change is going to be if we burn paper. Okay, so that was one of the physical or the chemical properties, is it reacts with oxygen, it burns. So paper does burn. If we light it on fire and we burn the paper, we can't get the paper back. It didn't just change the physical appearance of it, it changed it into a completely new substance. So that would be a chemical change. Chemical changes, you can have stuff, like I said, that burns. You can have temperature changes. Forming a gas or a bubble. So if you mix two chemicals together and they start to bubble and form a gas, that would be a chemical change. Forms a precipitate. Precipitate is a new word for you. You've probably not heard that before now. A precipitate is just where a solid forms in a solution. So this would be like if you mix two liquids together and they form little crystals in the solution. That would be a precipitate. And that's always an indicator of a chemical change. I do want to talk to you about color changes. Color changes can be physical or chemical, so it's not always a good indicator. If it's a chemical change, like if you have iron sitting outside and it rusts and it forms that new reddish orange color on it, that is a chemical change, or witness a chemical change, because the iron was reacting with oxygen, it rusted and formed iron oxide. So it's not just iron anymore, it's a combination of iron and oxygen. So that would be a chemical change for color change. Physical would be like if you're mixing up some Kool-Aid. okay? And you put the water in, and you put the sugar, and then you put the little Kool-Aid packet. That Kool-Aid packet has food coloring in it. And it dissolves in the water, and it changes the color of the water, but it's still a physical change. It's not a chemical change. It didn't react to become a new substance. Okay? With chemical changes, you can have something that's called a catalyst added to a chemical reaction, and that all that a catalyst does is going to speed up the reaction. So it basically requires it less energy to complete the reaction. So if this is your normal reaction curve, okay, these would be your products, and this would be your reactants, and this would be the little peak up here. This is the energy required to run the reaction. See how it's a lot higher? This little dotted line I'm showing would be if you add a catalyst. It still has the same curvature to the graph. It just is going to lower the amount of energy, so it takes it less time. So think about it like this. If you're running, and this is up a hill, and you're coming down to the end, or if you're running up this little hill and coming down to the end, which one would take you less time? So it'd be the one with the little hill, the one that requires the least amount of energy, would require the least amount of time. So that's what a catalyst is. It just speeds up the reaction. So you can run the reaction a lot faster if you add a catalyst to it, and that's what they chemical reaction. So when you're mixing substances together and going through a chemical change.